Hi, this video is on finding the period of a sinusoidal function from a graph. And so the period of a sinusoidal function is the length of the curve before it repeats. So they're showing you here, from here to here is the period of the function. So if you start at the maximum, then you go down the whole way and back up, and then it repeats again. It's this length here. You could also start from the midline if you go up, the whole way down and back up, and then it starts again. It's going to have the same length. This would be the period if you're starting from the midline. It's going to be the same exact length as the period if you're starting from the maxes or the mins for that matter. Okay, so on this problem here, they're telling us we have this function that intersects the midline and gives us a coordinate for that, and it tells us where the maximum point is, and it's asking us to find the period of the function. So that means if we go down the whole way and back up, this length from here to here is going to be the period of the function. So this is giving us halfway down, and then we're going to go down some more, back up, and back up. So in other words, if we can find this length here and multiply it by 4, that's going to give us the length of the period, because it's broken up into 4 different things going on. Down to the midline, 1. Down to the minimum, 2. Back to the midline, 3. Whole way to the top, 4. And then it repeats. So if we can find this distance here and multiply it by 4, that should give us the period of the function. So what you do is we're going to subtract the x values. Now it's in terms of pi. So let's see. This one is negative pi. I'm not sure why my pen is highlighting it in a big yellow or a big circle there, but we're subtracting negative pi over 2, or negative 1/2 pi. We're taking that negative 1/2 pi minus negative 2 pi. Minus a negative is a positive. 2 negatives make a positive. So if we're subtracting fractions, negative pi over 2 or negative 1/2 pi. Sorry, I'm writing with my mouse. It's taking me a long time here. Plus, and then if we add on 2 pi, 2 pi is the same thing as 2 is the same thing as 4 halves. So if we have negative 1/2 pi plus 4 halves pi, that's 3 halves pi. So that's 1.5 pi. And then that's only 1/4. So then we're going to multiply that by 4. And if you multiply that by 4, 3 times 4 is 12, divided by 2 is 6 pi. So I think the period of the function should be 6 pi. Okay, let's try it out. 6 pi. And let's check it. All right, we got it. Okay, so here it says below is the graph of a trig function. It intersects at negative 2 pi over 3 or negative 2/3 pi, and again at negative pi, or pi comma negative 7. So if you go up, down, back to the midline, then the whole way down and back up, that's one cycle. So the period would be from here to here. So if we can find this distance from here to here and double it, we'll be able to find the period of the function. So it says my recording is going to end in 26 seconds. So if it ends, here's how you do it. You're going to take pi minus negative, so that's positive 2/3 pi. You're going to add those together and you'll double it. So pi is 3/3 plus 2/3 is 5/3. If you double it, it's going to be 10.